of The Origin of Life, which are primordial soup-based, which get published on a monthly basis to this day, all depend on things that life doesn't do. Yeah. And the universality of the process that Brian was talking about just then, chemiosmotic coupling, is what life does.
And protons to translate.
Yeah, right. So basically the idea that you've got more hydrogen nuclei, protons, on one side of a gradient than another, and the flow from that high concentration to a lower concentration powers, it's kind of like a turbine, powers and generates the energy that cells use. And almost without exception, all life does it. So for 100 years, we've been researching the origin of life by looking at things that life doesn't do, which is dim, right? That's a stupid way of going about this.
I should say, actually, Adam mentioned one thing there. I mentioned earlier that there are no laws of physics that we would consider absolute. There are also exceptions in physics. There is actually one that we probably do consider absolute. It's called the second law of thermodynamics, which essentially means that things tend to get more disordered over time. And the reason we think it's absolute is it's a statistical statement, essentially. So most physicists, I think probably all, would say if there's one law that we expect to be a law, really a law, it's that. And life, at first sight, appears to run counter to that. We are obviously very ordered structures. You know, the human brain is I said in the presence of Alice Roberts, it's the most ordered structure in the universe, and she said, no, it isn't. An elephant brain's more ordered.
And she's wrong about that, and I checked it out, and she is wrong about that.
Good. Mammalian brains
to defend herself.
Mammalian brains are but anyway, so we're ordered structures. But what we do know in physics is that if you have out of equilibrium systems, right, so gradients, be it protons or whatever, then you can generate local order, right? You do work essentially. So it's literally, in a physical sense, that you do work and you can generate local order at the expense of more disorder elsewhere, it has to be said, but you can generate it. So you get systems that become spontaneously ordered in the presence of gradients. And that's the key point, I think, isn't it? It must be. We are incredibly out of equilibrium systems. Yes. Everywhere in our bodies, we're working, most of the energy we get from our food is taken up, keeping us out of equilibrium so that we can do things. We're a process.
That's
just
right.
living.
I think, and when you die,
said, it's a great quote. He said, "Really, the question is not what is life, but what is living."
What is living? That's exactly right. And when you die, that process stops, and we become eventually in equilibrium with the rest of the universe, and we succumb to the non-negotiable law of the second law of thermodynamics. But the beauty and the thing that I absolutely love this concept, is that process has been continuous for 4 billion years in a perfect, unbroken chain. And it happens in every single one of your cells right now, and every single one of those cells was born from an existing cell, which ultimately goes back to your fertilized egg that you grew from, which ultimately goes back to the fertilized egg of your parents, and you can trace that pathway where every single one of those cells was doing exactly this process and DNA replication all the way back 4 billion years to the origin of life. And it is unbroken. There are no cells, according to how we understand how life works, that don't adhere to that model, which is an incredible thing, hand up straight away.